Hello guys, how are you today? So today I'll be explaining the Algebra Course Practice section 6.3. So let's start with the first question. In the first question they said, the first and second terms of a geometric progression are 1 over 10 and 7 over 2 respectively. What is the common ratio of this progression? Because we are dealing with a geometric progression, to find the common ratio, it's going to be the second term divided by the first term. So very simply, on your calculator you can put 7 over 2 divided by 1 over 10, so that you will not mix up. Put it like this: 7 over 2 divided by 1 over 10, so that you will not mix up and get any mistakes, and you will get an answer of 35. We move on to the next question. What is the sum of 12 plus 12 times 0.7 plus 12 times 0.7 squared plus 12 times 0.7 to the power of 3 plus 12 times 0.7 to the power of 4 plus, and then there is dot dot dot. Whatever the dot 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 means, this means to infinity. So whenever they ask for sum to infinity, then we will use the equation a1 over 1 minus the common ratio r, and you will find the sum to infinity. So a1, it is what? It is 12 over 1 minus the common ratio. How do we find the common ratio? We will do second term divided by first term, and we will get the common ratio to be 0.7. So come on the calculator and put 12 over 1 minus 0.7, and you will get an answer of what? Of 40. So the sum to infinity, it is 40. We move on to question number 3. What fraction in lowest term is equal to the 10th term of a geometric sequence if its first term is this and its common ratio is this? You should know that geometric sequence an, it is equal to a1 times the common ratio r to the power of n minus 1. So an, which is a10 that we need to find, it is equal to a1, the first term, 2 to the power of 7 over 3 to the power of 6, multiplied by the common ratio 3 over 2, and the common ratio is to the power of n minus 1, so 10 minus 1. We will put it on the calculator. Okay, so put it on the calculator, and you will get an answer of 27 over 4. We move on to question number 4. The first two terms of a geometric progression are 1000 and 100 in this order. Find the next 4 terms of this progression and then fill in the blanks with integers or decimals as convenient. They need the next 4 terms being 3rd, 4th, 5th, and 6th. So we have to make a general rule. We know that an, it's equal to a1 times r to the power of n minus 1. We have a1, it is 1000. But we do not have the common ratio. We have the second term to be 100 and the first term to be 1000. So the common ratio is going to be 100 divided by 1000, and you will get your answer to be 1 over 10 to the power of n minus 1. So for the third term, it's going to be a3 is equal to 1000 times 1 over 10 to the power of 3 minus 1, and you are going to get an answer of 10. For the fourth term, a4 is equal to 1000 times 1 over 10 to the power of 4 minus 1. You will get an answer of 1. Then a5, it is 1000 times 1 over 10 to the power of 5 minus 1. And you will get an answer of 0.1. And finally, a6, it is equal to 1000 times 1 over 10 to the power of 6 minus 1, and you will get an answer of 0.01. So third term is 10, fourth term is 1, fifth term is 0.1, and the sixth term, it is 0.01. We move on to question number 5. G is a geometric progression with first term g1, 1 over 2, common ratio r, radical 2. Fill in the blanks. We need to find g3, g7, and g11. To do that, we need to make a general equation. For the geometric progression, it is an is equal to a1 times r to the power of n minus 1. So, an, in this case, it's going to be 1 over 2 times r, to find the common ratio r, actually no need to find it, it's given to us, to the power of n minus 1. So if we are dealing with a3, it would be 1 over 2 times radical 2 to the power of 3 minus 1. So put it on your calculator and you will get an answer of 1. For g7, it would be g7 is equal to 1 over 2 times radical 2 to the power of 7 minus 1. Put it on the calculator and you will get an answer of 4. And then finally, g11, it is equal to 1 over 2 times radical 2 to the power of 11 minus 1, and you will get an answer of 16. So 1, 4, and 16. We move on to question number 6, okay? So in question number 6, they said write the repeating decimal 1.0909 in a fraction in lowest terms. Now I will explain it to you how to do it, then I will give you a very much easier way to do it. So first of all, x is equal to 1.09 repeating symbol. You have to make sure that after the decimal place there is no non-repeating digits. So everything after the decimal place should be repeating. Now how many digits are being repeated? 2 digits. That means you're going to put 1 and 2 zeros. It's equal to 109. So you multiply 1.090909 by 100. You will get 109.09 repeating. Okay, now you're going to subtract both sides. You will get 99x is equal to 108. Alright, and then after solving, you will get x is 12 over 11. Or another way is on your calculator, you put 1.0909090909090909, just like make it a big number, and you will directly get 12 over 11. So 2 ways to do it. They're both just like each other. Okay, now, what number is equal to the sum of the first 12 terms of the geometric sequence 1, 3, 9, 27? So what we need to find the sum, okay? We need a1, we need the ratio, and 1, it is a whole number, so we don't need to find it. So we have a1, it is 1. And to find the ratio, we'll divide second by the first, we will get 3. So now a1, which is 1, multiplied by 1 minus the ratio, which we found to be 3, to the power of n, so it's the first 12 terms to the power of 12, over 1 minus the ratio. So again, it's a1, I'll write the general formula up. It is a1, okay, times 1 minus the ratio to the power of n over 1 minus ratio. So if you put it on your calculator, 1 times 1 minus 3 to the power of 12 over 1 minus 3, you're gonna get an answer which is 265,720. So this is very simply our answer, 265,720. We move on to question number 8. What is the value of the sum of all the terms of the geometric sequence? All the terms and other terms means infinity. So this geometric sequence, to find the sum at infinity, we know that the general rule, it is a1 over 1 minus r to find the sum at infinity. So we need a1, which is 1,000. We need to find the ratio r, so we're going to do 500 divided by 1,000, which is 1 over 2. So very simply, it will become 1,000 divided by 1 minus 1 over 2. So you will put it on the calculator and you will get an answer of 2,000. Let me just check. 1,000 over 1 minus 1 over 2. Yes, you will get an answer of 2,000. We move on to question number 9. Here again, there's 2 ways to do this. There's either you do x is equal to 2.14, etc. And then you make sure that nothing after the decimal place is a non-repeating digit. Then how many digits are being repeated to? So 1 and 2 zeros. X is equal to 214.1414 ... You subtract them, you will get 99x is equal to 212, and then very simply x is 212 over 99. This is one way to do it. Another way, you put on your calculator 2.1414141414141414. You put equal, and you will get 212 over 99. We move on to question number 10. Now for question number 10, we have to make for each of them their general rules. So for you, as you can see, it's a geometric sequence. We are multiplying by 4. Okay, so the rule for the geometric sequence, it is a1 times the ratio to the power of n minus 1. We have a1, which is 3, and we have the ratio, which is 4. So very simply, it's 3 times 4 to the power of n minus 1. Just like that, we finished u. For v, as you can see, we keep on increasing by what? We keep on increasing by 4. So plus 4, plus 4, plus 4. So this is an arithmetic sequence. And we know that for the arithmetic sequence, we have two major ways to do it. It is either a1 plus n minus 1 times the common difference d. You could do it like this. Or another way is to follow the rules of the slope. So y equals mx plus b. You follow it like this. X, we will just switch it to n, and m will be what? M will be what we are jumping, how much we are adding for every number. So as you see, for every number we are adding 4. That means it's gonna be 4n plus, now b, it is what? It is the first term, which is 7. You are gonna subtract it from the common difference, which is 4. So 7 minus 4, it will leave us with 3. So very simply, just like that, we found v. It is 4n plus 3. Now fn, because it's a fraction, you do the numerator by themselves and the denominator by themselves. So as you can see in the numerator, what is happening? You are continuously adding by 1. And they told us down that its f is equal to n plus over n plus. Okay? As you can see over here, we are continuously adding by 1. So that means it's going to be n plus 1. N means what term it is. Okay, this is the first term. So 1 plus 1, you will get 2. This is the second term. So 2 plus 2 is 2 plus 1, you're going to get 3. Whereas for the bottom, you are continuously adding by 1 as well. But there's a small issue over here. They said n plus. If we put n plus 1, then it would have to be the same as the numerator. So we will not put it as n plus 1. Instead, what we're going to do is we're going to take the common difference, which is 1, and we're going to take the first value, which is 5, and we're going to subtract. So 5 minus 1, and you're going to get 4. Now let us check. N, first term, it's going to be 1 plus 4, you will get 5. And this is the third term, so 3 plus 4, you will get 7. Yes, this is correct, so we are gonna keep it. So it becomes n plus 1 over n plus 4. Now, finally, for the last one, this is a quadratic sequence. So let us see what they mean by quadratic sequence. Whenever you experience these type of sequences, it is preferable that you make a big table, okay? And you put the values in each table. So we have 5, 12, 25, and 44. Now, in the bottom, what we are going to put? We're going to put 44 minus 25. You're going to get 19. And then 25 minus 12, you're going to get 13. And then 12 minus 5, you're going to get 7. Here, you leave it empty. Okay? Now, what will we do over here? We're going to do 19 minus 13. This is 6. And then 13 minus 7, this is 6. You will also leave this blank. Now, accordingly, for the very last row you get in the quadratic sequence, first of all, how do we know it's a quadratic sequence? Because it has only 1, 2, 3 rows. If it has only 3 rows, then it's a quadratic sequence. What you need to know is that the third row, the constant value, it is 2a is equal to this value. So 2a is equal to 6. That means a is equal to 3. For the second row, the first value, which is 7 in this case, it is equal to 3a plus b. So it's going to be 3 times 3 plus b is equal to 7. So 9 plus b equals to 7. That gives us b as minus 2. So we have a, we have b. Now for the last one, which is the first value in the first row, which is 5 in this case, it is equal to a plus b plus c. Okay? A is 3, b is minus 2, plus c is equal to 5. So 1 plus c is equal to 5, c is then equal to 4. Just like that, we found the 3 values. So we said a is 3, b is minus 2, and c it is 4. Now finally, we will move on to question number 11. What is the sum to infinity of a geometric series if its first term is 48 and second term is 36? We know that sum to infinity, the general formula is a1 over 1 minus the ratio r. So a1, we know it is 48. So 1 minus the ratio r, how do we find it? We are going to divide. So 36 over 48, this will give us 3 over 4. So 48 over 1 minus 3 over 4. And you put it on the calculator, you will get an answer of, 1 second. You will get an answer of 192. And just like that, we found the last question. Let's submit and hopefully there are no mistakes. And thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.